Good morning, I'm Dr. Janardhana Rao. We are discussing about operating system different concepts. So far, we have seen the theory part and some of the concepts. And today we are going to discuss about this programmatic concept, that is for page replacement, that is paging algorithm. And we will see first of all page replacement algorithm. Why we go for the page replacement algorithm? So first of all, this is one of the virtual concept, virtual memory concept. So as we discussed in the earlier, suppose we want to see one file. The file is having 4 GB, that is in the hard disk. 4 GB, that is in the hard disk. This is our maybe in D drive or C drive. But if we want to see this 4 GB file in the, we want to see open that one. If you press this one, so this has to come to RAM. Your RAM size is less. Your RAM size is after occupying OS, we got only somewhere 2 GB maybe is available. Just think it. So 4 GB file you want to see in the 2 GB. It is different. So in that case, we go for the paging concept, the paging with the virtual memory. So in this case, what we do, whatever the 4 GB file, will make into frames, and your 2 GB file is made into this is frames, this is your frames, and this is the pages. So page size and this frame size and frame size should be, suppose if you are making 10 KB, so this is also 10 KB. So like this we make the pieces. So now whatever the how many number of frames available in this RAM, that many will be brought here. So suppose there are 10 available. In this 10, first 10 pages, 10 pages transferred in this one, will maintain the paging table. In this one, which frame, this is a frame, and which page is coming to which frame. So like this, we will maintain page table. So after after seeing the 10 pages, we want to see the 11th page. 11th page is available in the hard disk. So that 11th page should be brought into the RAM. This is our RAM, main memory. So, but there is no place in the RAM. No place, because already whatever the available space is available in the RAM, there are all these places occupied by this first 10 pages from the hard disk. So now we want to the 11th page. 11th page in the hard disk. So we must swap out we must clear one of the frame. You must clear, you must vacate, you must delete, or you must empty. So then we will bring this 11th page into the whichever the frame free or vacated. So that's called page replacement. Which page to be replaced? Which page to be replaced in the RAM? So that's called page replacement. So for our program, we required the above strings, above pages are required for the execution of one program. So in this one, what is the sequence? 3, 1, 2, 1, 6, 5, 1, 3 with 3 page frames. But what it means, in the RAM only 3 frames are available. RAM only 3 frames. So for our execution, so how many pages required? 3, 1, 2, 1, 6, 5, 1, 3. These are the required, rather you can say page numbers, that is in the hard disk. So for execution of this one, so we go for the page replacement algorithm. The page replacement algorithm, so in the RAM, so there are 3 frames available. So now we will see how it is executing. In the RAM only, this is our RAM, this is OS occupied, only 1, 2, 3 frames available. So but there is no place for the 4th place. So but whereas in the numerical, this is a page required for the execution of the particular program. So we go for the page replacement. Which page to be replaced in this sequence? So first you will see this in numerical one by one. So the page replacement algorithm decides which memory page to be replaced. The process of replacement is sometimes called swap out or swap write to disk. Page replacement is done when the requesting page is not found in the main memory or memory, the RAM, the page fault. That's called page fault. So we require 11th page. But the 11th page is not available in the RAM. That is we call phase fault. Whenever phase fault occurs, automatically we will go for the phase demand. That page we are demanding page 11. That phase is not available in the RAM. So immediately when this is not available, we call it phase demanding and phase fault. Whenever we are demanding one page, 11th page, that is called page demanding. Once the 11th page is not available in the main memory, that is called phase fault. Whenever the phase fault occurs, so the page replacement algorithms decides which memory page to be replaced from the RAM, so that the 11th page which is available in the hard disk, that should be brought into the RAM. So this process of replacement is sometimes called swap out or swap to disk. Page replacement is done when the requested page is not found in the main memory. So the page replacement algorithm decides which memory page to be replaced. The process of replacement is sometimes called swap out or write to disk. Page replacement is done when the requested page is not found in the main memory phase fault. The virtual memory, the page replacement frame allocation. If the number of frames which are allocated to a process is not sufficient to accurate, then there can be a problem of thrashing. Due to lack of frames, most of the pages will be residing in the main memory and therefore more page faults will occur. If OS allocates more frames to the process, then there can be internal fragmentation. If the page replacement algorithm is not optimal, then there will be the problem of thrashing. If the thrashing is maximum output of the system CPU. If the number of page faults are replaced by the page that are replaced by the requested page will be referred to the near future, then there will be a more number of swap in swap outs, and therefore the OS has to perform more replacements than usual, with causes performance efficiency. Therefore, the task of an optimal page replacement algorithm is to choose the first page which can limit the thrashing. So thrashing, the CPU will be tied. So types of page replacement algorithms. Optimal page replacement algorithm. This algorithm replaces the page which will not be referred so long in future. Although it cannot be particularly implemented, but can be used as a benchmark. Other algorithms are compared to this in terms of optimality. Least recently used LRU page replacement algorithm. This algorithm replaces the page which has not been referred for a long time. It has not that in the RAM only, but is not used recently. This algorithm is just opposed to the optimal replacement algorithm. In this we will look at the fast instead of starting at future. So we will see that FIFO in this algorithm, the queue is maintained. The page which is assigned the frame first will be replaced first. In other words, the page which resides at the rear end of the queue will be replaced on the every phase fault. We will see the examples in this one. In the first in first out algorithm, older page in the main memory is the one which will be selected for the replacement. Easy to implement. Keep a list, replace pages which from all tail and add new pages at the end. So this is our requirement reference text for executing any program. So we require this one. So 0 2 1 6 4 0 1 1 0 2 1 2 1 is the sequence of the pages required. So suppose starting 0 is loaded, because we'll see this is a RAM capacity, only 4 frames available, only empty 4 frames. So now initially 0 is occupied, another 2 is there, 2 is occupied, and 1 occupied, and 6 occupied. So this is the first. So we will see that why the cross is there means miss. This is not initially starting means these pages are not loaded, so that is not available in the RAM. So this is, so we will get the into marks here. So that is called fail, that phase fault. We call it is a phase fault. Now, so once the 4 frames are filled with the 4 pages, next we want to see, we want to go for the 6th one. We want to go 6 also occupied. Now want 4. This 4. This 4. This for 4 you want 4. So 4 is not here. That is called miss. This is called miss. In case of miss, so that is called phase fault. When phase fault occurs, automatically you go for the, we are demanding phase 4. That phase is not available. So that is called phase demanding phase fault occurred. When the phase fault occurs, it will call the page replacement algorithm in the which is available in the OS. The page algorithm we selected first in first start. So which page to be removed from this frames? So first in first start means 0 has come first, so we'll remove 0 and put inside the 4. This is the only sequence of the first in first out. Now 4 is occupied. Now 4 is occupied. Now what is the next sequence? Next sequence is 0. So since 0 is there already, 0 is there, it is there. So 0 is there. So no need to disturb that one. Already 0 is there. So the 0 will be brought as a statement says oldest page in the memory is the one which will be selected for replacement. Easy to implement. Keep a list. Replace pages from the tail and add new pages at the head. So remove this. So 0 will once we have inserted the 4. Now next one is you want 0. 0 is there. So 0 will be inserted here. This is adjustment, internal adjustment of this algorithm. So like this, whenever the string is not available, that is we call miss or phase fault. Whenever phase fault occurs, then automatically it will call the page replacement algorithm. That page replacement algorithm will be executing and it will replace one of the frames or clear one of the frame and get that page into that frame. So this is called first in first start. So optimal page algorithm. This is optimal page algorithm. In the optimal page algorithm, an optimal page replacement algorithm has the lowest page fault rate of all algorithms. An optimal page replacement algorithm exists and has been called OPT or min. Replace page that will not be used for the longest period of the time. Use this time. Use the time the pages to be used. So this one, these are the strings or pages we require from the hard disk. So we'll see. So this is only 4 frames available in the RAM. So now the first 4 occupied, first 0, 2, 1, 6 occupied here. So next problem starts after that. We want 4. We want 4. So which phase to be removed? This one. Out of this 4, which frame to be removed to insert the 4? That is the question. So in the first come first serve, which has come first, that is replaced. So here in the optimal, the condition is that replace the page that will not be used for the longest period of the time. That is it. So in that case, which page is not used for the longest period of the time, that will be removed. So now recently 6 has come. So we assume that 6 will not be used for the longest period because that's the assumption that 6 will not be used for long duration. Okay. So just now it has come. So we don't use this one for a long period. Now another sometime. So then that will be replaced. That page is replaced here. So 6 is replaced with the 4. So this is a page replacement algorithm. Optimal. This is called optimal page replacement algorithm. So now we'll go for another algorithm. So these are the phase faults. Okay. So the phase faults are 6 by total strings 12. So this is a condition of the fault rate. So next page replacement algorithm, least recently used algorithm. Least recently used. So here, as you know, as a least recently used algorithm, so a page which has not been used for the longest time in main memory is the one which will be selected for replacement. So we require one page. So now there are 4 frames. So 4 are occupied in the RAM. So we want next one. Next one is the fourth one. So then we want fourth one. Fourth one is not available yet. Then we are demanding fourth. That is called page demanding. Whenever page demand occurs, that will check that page is available in the RAM or not. If it is not available, that is called page fault. Whenever the page fault occurs, then automatically it will call the page replacement algorithm. Once you select this LRU, in the as for the LRU logic, that will be done. So here we want fourth one. So as for this statement, the longest time is the one which will be selected for replacement. So here 0 has come very long back. 0 has come very long back. So that page will be replaced and that 4 will be inserted there. Because we assume that longest time in the main memory. So since 0 has come first, so 0 is the longest time it is staying in the RAM. So for that reason we call that frame should be removed and we create the place for the next incoming page. So that will be like this. The pages will be inserted, and we calculate the fault rate, total number of page faults by total number of strings. That is 8 by 12. That is 0.67. So page replacement algorithms, other than this, these three and first in first out and LRU and most optimal. Other than this, some other page replacement algorithms also there. That is to get a process start quickly, keep a pool of free frames on the page fault. On page fault, select a page to be replaced. Write the new page in the frame of free full, make the page table and restart the process. So least recently used least frequently used algorithm. The page with the smallest count is the one which will be selected for replacement. So most frequently, we don't use number of times. So that's not required. So we replace that phase with the coming page. We for that phase coming page what page to be inserted. For that one we will clear that frame which is least frequently used in the operation. So most frequently used algorithm MFU. So this algorithm is based on the argument that page with the smallest count was probably just brought in and has to be used. So the main memory of the operating system is divided into various frames. The process is stored in these frames, and once the process is saved in the frame, the CPU may run it. So as a result, the operating system must set aside enough frames for each process. As a result, the operating system uses various algorithms in order to assign the frame. There are mainly 5 ways of frame allocation algorithm. The ways these are as equal frame allocation, proportional frame allocation, priority frame allocation, global replacement allocation, local replacement allocation. So equal frame allocation. In equal frame allocation, the processes are assigned equally among the processes in the ways. For example, if the system has 30 frames and 7 processes, each process will get 4 frames. So the 2 frames are not assigned to any system process, may be used as free frame buffer pool in the system. Disadvantages in the system with process of varying sizes, assigning equal frames to each process makes little sense. Many allotted empty frames will be wasted if many frames are assigned to a small task. So allocation of frames in this one, proportional frame allocation. The proportional frame allocation technique assigns frames based on the size needed for execution and the total number of frames in memory. So the allocated frames for a process PI of size SI or size R A equal to allocation equal to SI by S into M. in which S represents the total of the process size and M represents the total number of frames in the system. So the only drawback of this algorithm is that it doesn't allocate frames based on priority. Priority frame allocation solves this problem. So priority frame allocation, in the priority frame allocation assigns frames of the frame, a number of frames assigned based on the number of frames allocation on the processes. Suppose a process has high priority and require more frames, that many frames will be allocated to it. Following that, lesser priority processes are allocated. So these are the allocation of frames to the processes. Global replacement allocation: when a process requires a page that's not currently in memory, it may put it in and select a frame from all the frame sets. Even if another process is already utilizing this frame, in other words, one process may take frame from another, that is preemptive. So advantages: process performance is not hampered, resulting in higher system throughput. So the disadvantage is that the process itself may not solely control the page fault ratio of the process. The paging behavior of the other process also influences the number of pages in the memory per process. So local replacement allocation: when a process requests a page that is not already in the memory, it can bring it in and assign it to a frame from its set of allocated frames. So the paging behavior of a specific process has an effect on the page in the memory and page fault ratio. So the disadvantage: a low priority process may obstruct high priority processes by refusing to share its frames. So thrashing. What is a thrashing? Thrashing is when the page fault and the swapping happens very frequently at a higher rate, and then the operating system has to spend more time swapping these pages. This state in the operating system is known as the thrashing, because thrashing, the CPU utilization is going to reduce the negligible, because CPU utilization is the degree of multiprogramming. So this swapping is swapping out, because whenever the phase fault occurs, then automatically OS has to create the space in the RAM and get that page from the hard disk. That takes time. If it is happening frequently in the system, then system performance will hampered. So that is the main reason why thrashing. Thrashing is this is a peak. So if the multiprogramming, if number of swap in swap outs are more, so then OS will be busy with the thrashing only, this swapping in swapping out. When the OS will get the time to implement other jobs, that is the only main drawback in the thrashing. So we have to minimize the thrashing. So minimize thrashing means minimize the swap in swap out. So that is which page replacement algorithm will be more effective for the thrashing. So minimize the thrashing. So thrashing this is the main drawback of the multiprogramming. Thrashing is when the page fault and swapping happens very frequently at a higher rate. Then the operating system has to spend more time swapping these pages. So this is swapping. Thrashing is when the page fault and the swapping happens very frequently in a higher rate. Then the operating system has to spend more time swapping these pages. This state in the thrashing system known as thrashing. Because of thrashing, the CPU utilization is going to be reduced or negligible. So algorithms during thrashing, this we have seen: global page replacement and local page replacement algorithm. Whenever thrashing starts, the operating system tries to apply either global replacement algorithm or local replacement algorithms. So that already we discussed the global replacement algorithm and local replacement algorithm. So in the global replacement algorithm, global page replace can bring any page, because it is autonomous, you can say. So it tries to bring more pages whenever thrashing is found, but what actually will happen is that no process gets enough frames, and as a result, the thrashing will increase more and more. Therefore, the global page replacement algorithm is not suitable when the thrashing happens. So this is the drawback of the global. But another one is local page replacement. The local page replacement algorithm will select pages which only belong to that process. So there is a chance to reduce this thrashing, but it is proven that there are many disadvantages if you use local replacement, page replacement. Therefore, local page replacement algorithm is just an alternative to global page replacement in thrashing scenario. Causes of thrashing OS. There can be three main causes of thrashing: higher degree of multiprogramming, less number of frames compared to the process requirement, the process scheduling scheme which swaps in more processes when CPU utilization is low. So these are the thrashing causes. So we'll discuss some of the concepts in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.